Hello everyone. So today we're going to go ahead and start with Unit 5, Lesson 4. We will be talking about rhombi, the plural for rhombus, as well as properties of squares, and then plenty of examples for you guys to work on for practice. Okay, so we have the shapes we've worked with so far explicitly have been parallelograms and then rectangles. So today when we talk about rhombi, we're going to go ahead and create a few more properties that are going to be relevant to this shape. Now I'm going to go ahead and sketch myself a little rhombus here. If you'll notice, a rhombus is just kind of like a fancy square in that it's like an italicized square. Ugh, I'm really not getting the drawing well over here. I'll give it one more shot. Let's just do that. Okay, so there are a lot of similar properties of parallelograms, and we'll go over those again. So opposite sides are congruent. Let's put those notations. Opposite sides are also parallel. One arrow, two and two, two and two. Opposite angles are congruent, so we've got a little arc here and then a double arc on these two opposites. And then consecutive angles are supplementary, so, I forgot to name this. Let's call it A, B, C, and D. So A plus D would equal 180, A plus B would equal 180, B plus C would equal 180, and D plus C would equal 180, okay? Diagonals bisect each other, so that's like where we're cutting our diagonals in half. We've seen plenty of examples of those in the last two lessons. And then the properties that are very relevant to rhombi is that all four sides are congruent. So if I look at this shape, I'm actually going to go ahead and get rid of one of these lines. So, and I'll highlight it in a brighter color. So all four sides are actually the same length. So if BC was 7, everything else would also be 7. Then it says diagonals are perpendicular. This one's really fun. So if I'm cutting a diagonal from A to C and then a diagonal from D to B, this is basically saying that when you do that, you've actually created a 90-degree angle at each one of these corners. So you will no longer have to try to find that missing inside degree. It's just automatically going to be 90. And then the last one is that diagonals bisect opposite angles. And this is the first time we've seen this. So for example, if B was, let's say 90, no, I don't like that. Let's say it was 80 degrees, right? That means that this diagonal, which I'm going to over highlight in orange, has now cut B in half, which means this part of B is 40 and this part of B is also 40, okay? Likewise, if C is 100 degrees, the diagonal at AC has cut that C in half, so this part will be 50 and this part will also be 50, okay? Yeah, so I really like rhombi. I know it seems like there's a lot of rules to memorize here, but a lot of it is just also really, really intuitive. Let's get started. Question number 1 says, if JK equals 12 and JN equals 7, let's find the rest of these. We're going to start with labeling. JK as 12 and JN, this little bit, has 7. So I know that all four sides are congruent. So if JK is 12, everything around it is also going to be 12. I also know that diagonals bisect each other. Not super relevant for this problem, but the diagonals bisecting each other creates perpendicular angles. So let's just look at this triangle like this, right? Again, we see a right triangle emerge from this shape. And when we see right triangles and we have missing sides, we want to use our ever so trusted Pythagorean theorem. So a squared plus b squared equals c squared. You only really have to determine what is c. And if you're already thinking, that's easy, it's opposite the 90 degrees. You're right, it's 12. A and B doesn't matter. I'm just going to make 7A and B will be my missing component, okay? So this, as I simplify, is going to be 49 plus b squared equals 144. If this step is like not necessary anymore, that's fine. Just go ahead and subtract 7 squared from 12 squared. That's totally fine too. 144 minus 49 is going to be 95. So square root both sides. I do believe we're going to come to a decimal today. So that's going to be approximately, I do like using the squigglies. If you don't, I'm not taking points off. 9.75 because I round it to the hundredths place. So this one here is going to be 9.75. Okay. So now let's fill in our answers with the appropriate numbers. JM, the left side, is 12. JL, which is this entire diagonal, is 7 plus 7, which is 14. And then MN, which is this little section here, it's bisected, it's going to be 9.75. And then MK, which is the entire thing, is going to be double, right? So 9.75 times 2 is going to be 19.5. If you're off by a 0.1%, that's fine. I'm not going to be nitpicky about it. Okay. All right, go ahead and go do 2 by yourselves. 3 is also very similar to that. Let's do 4 together because this one has to do with angles. All right. Now, I notice there's a lot of missing angles, but I'm only given one in the problem, right? So this is 38 degrees. This means I have to go ahead and try to solve everything around it. Well, I can still use my properties of parallels. So 4 is also going to be 38 degrees. I'm going to try to erase that 4. There we go. Okay. 8 is also easy because this is a parallelogram. Everything on the inside is going to measure at 90 degrees. So this is going to be 90. Okay. Well, this is also 90. Even though they didn't ask for it, I can still fill everything in. It will help me find the other stuff. I can now see that I have a triangle with 2 angles that are present. All I need to do is find 7. So 180 minus 38 minus 90. 7 is going to be 52 degrees. Okay. And then again, I can do my opposite interior. So 2 is also going to be 52 degrees, right? Okay. So notice something here. I want to see if you guys can try to like see the pattern emerge. Basically, each one of these triangles is the same in the sense that like they've just been rotated, right? So like remember that this is going to be all the same length. How do I say this without like saying it? Let me just use my tool. So let's say it's not going to rotate nicely. Okay, it's not going to rotate nicely. Basically, I'm just trying to show you that this triangle is pretty much just this triangle here. Okay. Actually, no, that's not a good demonstration. I'm struggling for words. Okay, let's just go back to the properties. Basically, let's see that property number 3 says diagonals bisect opposite angles, right? So whatever this total angle is that we don't know, we just know that this diagonal in orange has been bisecting it. So angle 5 is also going to be 38 degrees, and all of these have also been bisected. So if this here is 52, angle 6 is also 52. This is also 38, and this is also 52. Okay, that's basically what I was trying to say, but I did not have the very good words to do it. Okay, and then fill all of those in as necessary. Question 5, I believe based off of the examples we've done, you guys will be able to do this, no problem. You do need to use Pythagorean theorem at some point in question number 5. And then as we move on to squares, which I believe is just like by far the easiest one, let's just look at doing sample number 6 as an example. Okay, so ABCD, here are all the properties. All you really need to know is that squares have all the properties of a parallelogram, a rectangle, and a rhombus. There's nothing new that you need to watch out for in a square. So if ABCD is a square and AD equals 11, find each missing value. So AD is 11, BC is 11, DC is 11, and AB is also 11. Now, let's look at this. This is going to be a 90-degree angle, right? So this creates a right triangle. And notice that this and this side are the same, so I can use Pythagorean. 11 squared plus 11 squared equals C squared, because C is my unknown opposite, the 90. So 121 plus 121 equals C squared. That's 242 equals C squared, and C will be about 15.56. Okay, so that's the entire length of DB. Let's cut that in half and use a smaller pen here. DE is going to be 7.79 and EB is also going to be 7.79. Okay? And because diagonals are congruent, let's see, right here it says diagonals are congruent, AE is also going to be 7.79 and ECs will also be 7.79. Okay? The other thing is that in a square, they're all 90 degrees at the corners. And because the angles get bisected, these will all be 45 degrees inside those little triangles that are being made. So 45, 45, the sides being bisected create a perpendicular. So that's going to be 90. So everything is like, it's super easy to find. You just need to go ahead and place it in the correct spots. Please make sure you trace those angles correctly. Okay, and I was going to do an example between 8 through 11 using the expressions, but I think at this point, since we've done so many examples like them, I would like for you to try to attempt those yourself, okay? And then you have 2 pages of must-dos. This last bit here would have been a quiz that I gave last year to my students, but I've just created as a should-do so you can like check if you're on the right track. Consider it as part of your study guide for the test. And it's, instead of giving you the study guide all at once, I'm giving it to you like in sections, okay? All right, that's it for this lesson. I will see you in the next one. Bye.